Hello and welcome again, and let's go straight forward to solving some problems about energy. Now, question number one. It says here that the potential energy an object gains if it has a mass of 5 kilograms and was pushed on an incline as shown below. The answer is 250, 150, 200, or 700. Well, actually, this is really easy and straightforward. We know that the potential energy for the gravitational potential energy is equal to m multiplied by g multiplied by h, okay? Now, the mass, it's clear in the question, that's 5. G is equal to 9.8. And finally, h. Which value should I use for h? Should I use the 5 meters or should I use the 3 meters? Well, actually, h in this case is the height above the ground. So we are going to use this distance, the 3 meters. It's not the 5 meters. The 5 meters is the inclined distance, and it's not the distance used to calculate the potential energy. The distance used to calculate potential energy is the vertical distance. So in this case, it's going to be 3, and the closest answer will be equal to 150 joules. Question number 2. A spring with a springs constant equal to 500 newtons per meter has a length of 0.2 meters at rest, okay? If the spring was stretched so its length now becomes 0.5 meters, how much potential energy is this spring storing? Okay, now we know that the potential energy, but the elastic potential energy in this case, is equal to half k x squared. Okay, now half, it's clear. K, what's the spring's constant? We can see that the spring's constant here is k. So we multiply it by 500 multiplied by x squared. Okay, it's really important here to notice that it has an original length of 0.2 meters and it was stretched to become 0.5 meters. So which one of these is x? Actually, as we said before, let's imagine that this was the original length. It was 0.2. Now it's stretched and it became 0.5. So the distance in this case, x, is going to be the difference between these two, which is 0.5 minus 0.2. It's equal to 0.3 meters. So it's very important to concentrate. Half multiplied by 500 multiplied by 0.3 squared. And the answer is going to be A. Next question. The work done on a slingshot is 40 joules, okay? To pull back a 0.1 kilogram stone. So what it says that we use the slingshot to throw a rock upwards. The mass of the rock is 0.1. Now, if the slingshot projects the stone straight up in the air, so it's telling you that the stone is going vertically. As we said, it has a mass equal to 0.1, and it was thrown vertically. Now, what is the maximum height to which the stone will rise? So the slingshot gave the rock 40 joules. So this means that the rock's energy right now, it has energy equal to 40 joules. But what type of energy does it have? Well, since it's moving, it has kinetic energy. But this kinetic energy is going to be transformed into potential energy. And we will be talking more in detail about energy transformation in the next videos. But the simple idea here is all the energy that was given to the rock by the slingshot will be transformed into potential energy. So I can say that the potential energy is equal to m multiplied by g multiplied by h. Now, the potential energy inside the rock is going to be 40 joules. This is equal to the mass, which is 0.1, multiplied by g, which is 9.8, multiplied by the height, which is unknown, because it's asking me what is the maximum height to which the stone will rise. So the potential energy is equal to 40, mass, g, and h. So the unknown here is simply h. To find h, we will need to divide both sides by 0.1 multiplied by 9.8, and I will divide this side also by 0.1 multiplied by 9.8. This will give me h is equal to 40.8 meters. So let's see. We see that the closest answer is B, which is 41 meters. So the answer is going to be B. Okay, next question. An object weighing 15 newtons is lifted from the ground to a height of 0.22 meters. The increase in the object's gravitational potential energy is approximately the following. Okay, now we know that the potential energy or the gravitational potential energy is equal to m multiplied by g multiplied by h, okay? But look, we do not have the mass. We have the weight. So some of you will go, okay, it's simple. We know that the weight is equal to mass multiplied by the gravitational acceleration. And we know the gravitational acceleration, we know the weight, so we can find the mass. Well, actually, if you just concentrate just a little bit more, you can see that mg, which is equal to the weight, is already existing in our equation. So in other words, we can say that the potential energy is actually equal to the weight. So technically, it's the same thing. We can say that the potential energy in this case is equal to the weight, which is 15, multiplied by the height, which is equal to 0.22. This will give us an answer equal to 3.3 joules. Okay? Now, actually, if we look at this equation a little bit more deeply, we know that work or energy, work is equal to the force multiplied by distance, okay? Now, if we look at this equation here and we look at this equation right here, don't you think that they are very similar? How is that? Weight is a form of force. We know that weight is a shape of force and h is a distance. Well, actually, yes, exactly, because potential energy and all types of energy are another form of work, or they are work. We can say that energy is very similar, or it is similar to work. So we can say that this equation, it's clear that this equation is very similar to this equation right here. Question number 5. As an object falls freely, what happens to the kinetic energy, or the kinetic energy of the object decreases, increases, remains the same, and none of the above? Actually, if you're not sure of the answer for these questions, always start with writing the equation. The kinetic energy is equal to half multiplied by m multiplied by v squared, okay? So let's study these parameters and what changes if an object was falling. Okay, half is a constant, it won't change. The mass, will the mass of the object change while the object is falling down? No, nothing will happen to the mass. The mass will remain the same. What about the velocity? Will the velocity of the object increase while the object is falling down, or will it decrease? We all know that the velocity will increase as long as the object is falling down, and we know it's increasing by a speed of 9.8 because we know that the gravitational acceleration is 9.8. So we know that the velocity here is increasing, okay? And since the velocity is increasing, this will cause the kinetic energy also to increase. So the answer is B, it will increase. These questions are just a simple introduction to what's coming next. So stay tuned, where we will be introducing energy transformations. It's a very, very important topic. So I hope to see you in the next videos. Goodbye.